All right, so today we're going to start talking about the differences between standard and vertex form and what each of them give us in order to graphing, because this part of the unit is all about graphing. Standard form has some good points, but it's not quite complete. Vertex has some good points, but as we just showed last class, you still have to do some stuff to be able to graph even from vertex form. So neither one is great. And so before I show you guys how you can go from one to the other, we're going to show you how or what each gives us and then what we're still needing in order to graph it. So let's first go look up at standard form. So standard form, what it gives us our A. You do have an A in front, and it's the same A, we'll get to this in just a second, it is the same A that you have in vertex form. So if your A is greater than 1, it's going to stretch. If your A is between 0 and 1, it is going to compress, again ignoring the negative. And then if your A is positive, it is going to open up. If your A is negative, it's going to open down. So even in standard form, we have that A. We know that that transformation is still happening because it's still an A and it's still doing the exact same thing. But the other thing that standard form has is the C. And the C is your y-intercept. So in vertex form, we were having to plug in to find that y-intercept. Standard form, I don't have to plug anything in. I do have that y-intercept. And so your y-intercept is the ordered pair 0, C. Because remember, y-intercepts are ordered pairs. Don't forget to write them as ordered pairs. What you can do with standard form, most of the time, not all the time, is you can factor it. And your factors give you your solutions, and your solutions give you your x-intercepts. So you do have x-intercepts when you have standard form. And so that's also something that you can graph. So information that we do need our axis of symmetry and our vertex. That is something that we really do need when we are graphing so we can see really how low it is going when we do these. So let's look at this example. I have f of x is equal to x squared plus 2x minus 8. So my a is equal to 1, which really is just going to tell me it's going to open up. Great. It's not stretching or compressing. Wonderful. My C value is 0, negative 8. So I'm going to go ahead and graph that. I can factor that. I have two numbers that give me negative 8 that add up to be 2, and that's going to be 4 and negative 2. So that's the factor of x plus 4 and x minus 2. I set those equal to 0. And I get that x is equal to negative 4 and x is equal to positive 2. So I can graph those. I have an x-intercept at negative 4, and I have an x-intercept at 2. Your axis of symmetry is going to go in between those points. So axis of symmetry is going to go in between the points of the x-intercepts, okay? Because what's happening on the left is happening on the right. So I'm going to go one in on the left, one in on the right. One in on the left, one on the right. One on the left, one on the right, and there in the middle is my axis of symmetry with a smaller highlighter. So I do know that my H at least is negative 1, and I can reflect that y-intercept to the other side, but I still don't exactly know how low that goes. So I am still missing a critical piece of that graph. Okay, so this is sort of just showing you how you can't fully graph one entirely, at least with standard form. So vertex form. Vertex form gives you, we've been spending a lot of time on vertex form. So vertex form gives you your A, your H, and your K. And we know what A does. It's the same as above. A is going to, if it's greater than 1, it's going to stretch. If it's between 0 and 1, it is going to compress. If your A is positive, it is going to open up. If your A is negative, it's going to open down. Yes, I still want you to write it again, because the more you write it, the more it's going to stick in your brain. At least, fingers crossed. Your H is your x of your vertex. It is your axis of symmetry. So it is x equals h. And it will tell you if it is moving left or right. So if you have x plus h, it is going to move left. If you have x minus h, it is going to move right. We have spent days talking about that, and I feel really good about how you guys were doing with transformations. Your K is the Y value of your vertex, and that's about all K tells you. Oh, sorry, plus K, it's going to move up. Minus K, it is going to move down. Now, your axis symmetry, I did allude to it up above with H, but your axis symmetry is X equals H, and your vertex is HK. So what do we still need to graph? Well, what did we need to in order to graph on the last assignment? We still needed the y-intercept. We still need some other extra point to be able to reflect it across the axis symmetry. We just like to use the y-intercept because it's really easy to plug in a 0. Very easy to plug into a 0. So I'm looking at this example over here. F of x is equal to negative 2 times x plus 1 squared plus 4. So my a value on that is negative 2 or 2. It has a negative in front. So it is going to stretch and open down because it's got the negative out in front, and then the 2 is going to stretch it. My h is negative 1, which means it's going to go left 1. My k is going to go up 4, and my k value is a positive 4. My axis of symmetry is my h, so my axis of symmetry is x equals negative 1. And my vertex is putting my h and my k together. So my vertex is negative 1, 4. So when I graph that, I have negative 1, 4. So I'm going left 1, up 4. My axis of symmetry is 1. And as I showed you guys last class, that's all that vertex form gives me. And it's not enough to graph it. But what we did last class was we put in our y-intercept, and we found what that last point was. So that's what we're about to do right now, putting 0 in for x. Using our calculator, negative 2 parenthesis 0 plus 1 squared, and then plus 4. That is 2. So now I have a second point, so 0, 2, which I can reflect. Now, where we're going today is, wouldn't it be great if I'm given standard form, which gives me my y-intercept, I can easily convert it to vertex form. That way I have the vertex, and then I have enough to graph it just between the two. So that's what we're going to work on today, and you're going to go, if you are watching these videos, then you need to go to video 2 to watch the video of how we're going to go from standard form to vertex form using the axis of symmetry formula.